Welcome to this GCSE lesson on gas pressure and volume. So before you start this, you should already be able to describe the motion of particles in a gas, state what is meant by volume, explain the cause of pressure in gases using the particle model, and explain how changing the temperature of a gas changes the pressure. Answer these questions now, and if you're struggling on any of them, please review your notes from previous lessons. Pressure and volume. The number of particles which collide with a wall every second determines the pressure on those walls. The more particles colliding every second, the greater the pressure. Figure A shows what happens when the volume of a container of gas increases at a constant temperature. When the volume is greater, the particles have more space to spread apart. Since they are still travelling at the same speed, it takes longer for them to go from one side of the container to the other. This means they will hit the edges less often. Since pressure is caused by the number and speed of collisions, the pressure will be lower. It's important that the gas remains at constant temperature during this change in volume. If the gas changes temperature as well, that would also affect the pressure. So if we were doing an experiment on this, temperature would be a control variable. Test yourself. How do you know from the diagram that the gas is the same temperature before and after the change in volume? Give yourselves a moment to think. The answer is that we can see that the speed of those particles is the same before and after, as shown by the length of the arrows. Fill in the blanks. As the volume of a container increases, the pressure of the gas does what? And explain why this happens. So let's look at the pressure-volume relationship on a graph. We can see from figure A earlier on, as the volume of a container increases, the pressure in the container decreases. Figure B shows this relationship on a sketch graph. This relationship was discovered by two scientists. However, they did not perform an experiment to show it and did not publish a paper. So the law is named after Robert Boyle, who showed the relationship experimentally and then published the results for others to peer review. It was known as Boyles Law. As you can see from the graph, as we increase in volume, we decrease in pressure. Sketch a copy of figure B and name the relationship between the pressure and volume of a gas. You may recognize this graph from maths. It shows inverse proportionality. This graph shows us that pressure and volume are inversely proportional. Now you need to know and understand that this means pressure times volume will be constant. So if two things are inversely proportional, it means when you multiply them together, they give you a constant value. So if you multiply the pressure and the volume at any point on the graph, you'll get the same number. Describe the relationship between pressure and volume. Finding the new pressure or volume. Since we know that the pressure multiplied by the volume is constant, then if we know how one changes, we know how the other changes. If it increases pressure, it decreases volume. And we can say that the pressure at the start multiplied by the volume at the start is equal to the pressure at the end multiplied by the volume at the end. That's given by P1V1 equals P2V2. So for instance, if I increase the volume by 4 times, that would decrease the pressure by 4 times. If I increase the pressure by 3 times, that would decrease the volume by 3 times. Solve the following calculations using this equation or your own understanding of this relationship. A gas of volume 0.5 meters cubed and pressure 90 pascals is transferred into a container of volume 2 meters cubed. Calculate the pressure in this new container. A fire extinguisher has a volume of 0.04 meters cubed and is fully discharged into a room with a volume of 20 meters cubed at a pressure of 100 kilopascals. Calculate the pressure of the gas when it was in the fire extinguisher. And finally, a bicycle tyre of volume 0.00175 meters cubed is pumped to 4 times its original pressure. What volume of air was needed to do this? If you'd like to read through the textbook page, you can see it here with the questions that we answered earlier at the bottom right.